Hi everyone, uh, my name is Rohan Kapse and I am a full stack developer and a web3.js ambassador. And welcome to this video of blockchain basics with web3.js. In this video, we'll look how blockchains work from its origin to how it works, its applications, and how you can use web3.js to elevate your developer experience. So let's get started. So when we talk about blockchain, obviously, we talk about Web3, right? Since it is part of the Web3 whole ecosystem. And but the question that comes to mind is what is Web3? So Web3 is something you can call it as third iteration of web. So you can think of, for example, like the updates in the mobile phone, right? Every time you get some software update or application update. So Web3 is something similar in that sense. So since the beginning, there have been previous versions to it. It's just a refinement in the previous versions and adaptations to the new technology. So it's basically a third cycle of whole web since its beginning. But then there might have been so there you might be thinking that there would have been prior versions, right? Like web 1 version or web 2 version. You are right. And let's just talk about the prior versions now. So basically, this is the whole version of web, like how it has evolved over the time. And so first of all, let's talk about what web 1 version was, and then we'll jump to the web 2 and web 3. So web 1 is also known as read-only web. Now, why it's called read-only web? Because it's basically the very early development of internet, right? Somewhere around 1990s, 2000, around the dot-com burst and all. So it's basically the early development of internet, and some browsers that came into picture were Netscape, Internet Explorer, and so basically these were all static websites. Whatever the data on that websites existed because of the whatever owner was put on, right? So as a user, you couldn't interact with them, you couldn't see how the things work, or it's basically like these days, right? How you can interact with the apps, right? But that wasn't possible. It's only all static data, and yeah, that's basically the thing. So there wasn't any content generation by the users, and that's basically the web version, web 1 version summed up. So if we talk about how things evolved, then the updated version was called web 2 version or web 2.0. So it's also called as read write web because now it became more sort of interactive, dynamic, and so it's basically the rise of apps like Facebook and Google and Twitter, Instagram, right? So where you can create content like posting a tweet or posting a photo or etc. Right? So that's where users could interact, and yeah, so that's where it's also called as a read write web, and it became more interactive, dynamic, and that's the whole sum up of how the web 2 version works. Now we come to the web 3 version. So we still are using the web 2 version right now, and the thing is there's more advancement to this technology of the web 2 version, and then it became more advanced, sort of decentralized network. The web 3 technology, the web 3 cycle or the update is all about machine learning and how web 3 works, and all the advancements in the web 3 include read, write, and control. So it's basically in power of people, right? All the decentralized network. That's basically the Web3 version, which includes blockchain, machine learning, and all the advancements in the technology. So moving on. here's a picture which I want to show you. So here's the evolution of web, right? So when we talk of evolution, here's Netscape, here's Yahoo. So this was basically the so this was basically the the read only web. And here's, as I said, you could only interact with audio, interact with the websites, as they were only static websites. You could only view them or slash read them. And then we moved to the updated version of read write web, where basically you could create content like uploading YouTube video or Twitter posts and etc. And now we are into the Web3, scene or the ecosystem update, where a lot of influential things like Ethereum and Solana, blockchain and machine learning. So that's what Web3 is. So it's basically I could say this is the latest advancement of technology era we are in right now. So yeah. So next thing I want to talk about is blockchain, right? So yeah. So few things that a lot of people sort of have question about is machine learning part of Web3, or is it related to blockchain in any sort? So few things I want to clear, that machine learning and blockchain are different technologies, but they are whole included into the Web3 ecosystem. So they are part of all the advancements in the Web3 ecosystem, but they aren't related to each other. So although there are a lot of projects which work on integrating machine learning and Web3 frameworks, so uh, that's basically a thing, right? And few things other than that, blockchain was first tech associated with Web3. Yeah, so blockchain was, when we talk about Web3, machine learning has been part of research for a very long time, and a lot of its application came to highlight very recently, whereas blockchain was implemented with Bitcoin, and so it gained sort of very popularity, and that's why when we talk about Web3, it's mostly blockchain and all. So few things I want to, yeah, so that's pretty much it. And now let's talk about origin of blockchain, right? So first of all, I want to take you through the history of blockchain, like what really made the blockchain thing pop out, and all the decentralized institution thing come out, right? So first thing is, let's take an example. So first of all, I just want to uh, share that it's basically an example. It's not the very primary reason for the blockchain invention, but it's one of the reasons how a major centralized authority can disrupt trust of people, and that's the very reason why we need the whole Web3 ecosystem and the decentralized institution thing. So let's talk about 2008 financial crisis. So first of all, I want to talk about the thing that happened around the financial crisis, which was one of the major financial crises around 2008. And so what happened was, these financial institutions in US overutilized instruments to gain maximum profit. So what does it mean? Basically, there's all institution like banks and other financial institutions. What they did was they issued loans to people with poor credit histories, right? Because uh, they wanted a profit margin on that, right, in terms of interest and all. But what happened was, this due to this high risk and poor credit histories, they took a huge bet on these customers, and they started lending loans to this these people, and without any right procedural credit of history, and that's how after there was a housing market collapse, and prices fell significantly, which was one of the major reason of how these people couldn't pay back the money to this bank, and they sort of went into huge debt, and this caused a major setback to these financial institutions as they were in debt. And then what happened was the US government intervened into this situation and build these institutions out of this financial crisis. So, what can we learn from this situation, right? So, a few things I want to talk about are the progress. So, the second point is progress, where what happened was US government intervened, right? So, so to avoid these banks to get into complete bankruptcy, they bailed them out, they paid the debt all these institutions were in, which they did in sort of, uh, I could say, illegal way, because without checking the credit history of people and giving them loans out is very risky job, to be honest. So what I would say is the US government intervened, and the thing that majorly comes to my it may come to your mind is that this all these institutions like banks and all these financial institutions, right, or the governments, they have the right to intervene and play around the ecosystem, and they can utilize it to their own benefits, right? So these banks gave out huge loans uh, without checking the credit histories and all to people with poor credit histories, and the result was this led to bankruptcy situations and all. The thing was the 2008 financial crisis. Uh, what it did was it basically affected the common people. If you see, like, a lot of jobs, recession, and all that, right? If you see that, and that's the very major thing we talk about, as the powers exactly lie into these huge institutions, right? Governments and these supreme institutions. So the question that comes to mind is, why do only why do only they have the right to govern these things, right? All the major resources and utilizing them, exploiting them, and why a authority should decide for the people, why a single authority, and that too in such a financial crisis, which is a major reason for all the collapse of the you know stock market and all that. So this is why a group of people thought that there's need of decentralized institutions, as these centralized institutions exploit things to their benefits, and the people have to suffer for it. And that's what led to this. So this is basically the history and the progress of how blockchain, the very idea of why decentralization is needed and all. So when we talk of creation of blockchain, so creation of blockchain, basically it started with Bitcoin. So around 2009 or 10, something like that. Bitcoin was brought into uh, you know creation, and Nakamoto, who's an anonymous name, published the Bitcoin white paper, which so Bitcoin is basically a digital currency, which is application of blockchain. So that's the very creation of whole the blockchain ecosystem. I could say Bitcoin was the pioneer of the blockchain world and Web3 world. So that's how the Bitcoin was created, and that's pretty much it about the origin of blockchain. So what does blockchain mean? If we go by the standard definition, it means, a decentralized and distributed ledger technology across a network of computers in a secure and transparent way. Well, that's quite a lot of jargon, to be honest. And so I'll try to break it down in simple terms. You can think of it as a ledger. A ledger is basically, a digital record book. Let's say you have a friend, right? And you you owe some money to him, right? And let's say you owe him $100, right? And he owes you some certain amount, certain X amount. So what you do is you maintain the record of your friend and yourself as well in a book, like let's say in form of the transaction records, like you owe him, whatever, $100, he owes you any amount. And that's basically what a ledger is. So it's a book where you maintain a list of transactions, uh, recording all the previous transactions and all. So you can think blockchain as the ledger, or a digital ledger to be specific. And this is basically made of list of multiple accounts. So each block is made of list of transactions with its accounts and few things. It's basically in a sort of a chain. That's why it's called a blockchain, or a chain of blocks. One thing to keep in mind is this data is immutable, right? So once you put the record, let's say you owe your friend $100, uh, and you put a record into this ledger book. So once you put the record on a block in a blockchain, it's basically, it can't be deleted or manipulated. So by any chance your record can't be exploited by anyone except, no, not except, but it's like not even by you. So you have to be careful what you put into these records, right? So that's basically blockchain, how it how it sort of works, uh, like what it does. And yeah, I think I've covered all the points. Yeah, so it's covered now. This is basically how the blockchain, you know it's basically a sum up, or introduction to blockchain. Now let's just talk about the workings of blockchain. So here also I've divided these things in few points, like in terms of operation and how the previously we talked about network of computers, right? And distributed ledger, or a decentralized ledger. So that's where we can, I want to highlight this. So yeah, yeah. So blockchain ledger is collectively maintained by decentralized network of nodes. So if we think of this ledger where you owe your friend and all the list of transactions, let's say you have put into this record book of your friends, your family, relatives. So what you do is, what happens in blockchain is, this ledger record is maintained by network of nodes. If we see network of nodes, I just want to show you up real quick. Nodes in a blockchain network. So so yeah, in short, this is, you can think of this as a network of nodes or computers. And what happens is, each node into this circle maintains a copy of this ledger, right? So each individual led node, let's say this uh, are few nodes. So this each individual networks, nodes or computers in the network maintain this blockchain ledger copy. So the thing is, they have the access to your transaction records, or how how your ledger operates and all. So that's basically what decentralized means. So decentralized as of before. If we see, let's say, the ledger, it was only maintained by big companies, right? So like Facebook and uh, all these Google big companies, so they had all the access to your data. These were all central authorities, and so as consumers, you didn't have very much right over what was being done with your data. But here, the data is being distributed with all of the nodes in the network of blockchain. So you can say this is a decentralized network. Now, other things are, so blockchain uses DLT as discussed, which means decentralized ledger technology. Sorry, a distributed ledger technology, which we have discussed. It's the ledger distribution among all the nodes. So this has all the transaction recorded at multiple places. And one more benefit of this is no single entity has right. So if ledger, this entity tries to manipulate the ledger, then all the other entities in the network know about the exploits that this node is trying to do. So, and this is few other things that work in blockchain are, they use consensus mechanism. So basically, I'm trying to keep it short here, uh, like so yeah, I'm trying to keep it short. So what consensus mechanism means is, it's basically what blockchain technologies use. So there are basically two consensus mechanisms, which are proof of work and proof of stake. So proof of work is basically, miners show the work they put in, and they solve the equations to create the new blocks into all these new blocks into the network. So what does that mean is, basically miners are, we can say, they are sort of people who are responsible for creating these new blocks into uh, the blockchain, or putting up your transaction data, or uh, all the transaction details of the ledger onto the blockchain, right? So there are two processes, which mean, in proof of work, the miners, they have to solve some equations, like some mathematical equations. So just to show that they have put in work, and they have utilized the resources, uh, to and to show the work they have put in. So that's basically what proof of work is in short, right? To create new blocks. And proof of stake is basically, they put a collateral stake, where miners put something in return to create new blocks, right? So they might put some crypto assets or other assets as collateral, meaning if they try to manipulate the network data, or whatever the ledger data, their assets would be seized. And yeah, that's how basically proof of stake works. Now if we move on, uh, now I want to talk about operation, like how blockchains work. So this here is uh, blockchain, right? So let's just see what blockchain is all about, how it looks. So this is a blockchain, and consider this as a block number one, block two, block three, and block four, and this goes on endless, right? Now here you can see, here's a hash, right? So this block is nothing but a block number. So each block in the blockchain has a specific number associated with it. Here it's one, here it's two, here it's three, here it's four. So this goes on, and so yeah, so each block has a number associated with it. So basically, to identify the whole, where the transaction was recorded, or to identify the individual blocks in the network. And the next thing each block includes is nonce. Nonce means number only. It's basically, I think, yeah, wait a sec. I just need to check. Yeah, I was right. So it's basically number used once, and yeah, I wrote it down here. So it's basically a random number generated in a block with a particular set of rules and the data, right? This data section here includes all the transaction details, all the, records and the metadata. All that metadata is included in this data section. And the previous is, yeah, so before addressing hash, uh, I just want to, yeah, okay, that's fine. I think it's good. So previous here means it's the previous hash number. We'll talk about hash in a little bit. So this is basically previous hash number, and this is the hash of current data. So hash is basically uh, something which is generated. You can think of it as a random value generated combining this data and all this, data and metadata. So this previous here is basically hash of a previous block number, and the hash here, this hash represents the hash of the current block, like the block number one. So let's just talk about hashing and stuff. So hash function in short. So basically hashing is a process where there's a hash function where the data is put into hash function and it generates a hash code. Um, so this hash code is, sort of gibberish value which doesn't make any sense, but there's a hash function which is a mathematical function which uh, uses a mathematical formula to convert this data metadata, which includes the transaction details and all, into it's like a secret value, right? You can think hash of a secret, I don't know, secret. Yeah, so you can think of it as a secret value. And so that's hash. So yeah, so as of now, the in terms of cryptography, SHA-256 is the hash function which is majorly used in all the blockchain ecosystem. And what happens here is you write here some data like, hey, I'm Rohan, and here we have a look at hash value generation with, whatever. So this hash function, what it does is this input data, like we saw in this data, is converted into a hash value, right? So yeah, that's as I said, it's a gibberish value. It doesn't make any sense, but it does use a mathematical formula, uh, the hash function, which converts this all data into a very, uh, in sense, very secure uh, value, or the hash code. Now, if we see in blockchain, the if we look at the first block here, you can see there's a genesis block written. So what it means is, in a blockchain, there must be some start, right? So the genesis block is the beginning block in the blockchain, network. So it's the very first block created. Now what happens here is, in a hash function you can set also difficulty levels, like you know setting certain, like, three leading zeros or other etc stuff, so to just to make it difficult to decode. So one thing I want to tell you about hash code is it's very difficult to decode this, right? So yeah, if you were to decode as of now, it would take millions of computational resources. So it's basically, in short, it's very difficult to decode this until maybe we have some quantum computing stuff or anything like that. So yeah, so this is basically, in a blockchain, this is the first hash, sorry, the first block, which is also called as the genesis block. And as I've said before, the nonce is, and there's nonce, there's block number, there's transaction data, there's previous hash, which here is not defined, says it's genesis block. So what happens is, this is the hash value generated uh, from this transaction data, and this hash value is then set to this previous hash value in the next block, right? So now this next block includes this hash value, as you can see, right? 00 AB and whatever. So this previous hash value is here, and what it does is now block 2 is combines the transaction data of this with some hash value, previous hash value. So it basically performs a few things here and then generates a new hash value. So it goes on and on. So what it just combines the previous hash value, some transaction data, creates new hash value. Then again it goes on, and the process is like it goes on. This is, if you see, it's computationally uh, quite. That's why it's computationally quite difficult to crack the blockchain, space, as hacking the blockchain space, because you can see how complex these things are. Uh, So yeah, that's pretty much how blockchain works in brief. And next thing I want to talk about is um, applications of blockchain. So all we have seen up until now is how origin of blockchain and its working, and how things operate in the network and all that, right? So let's just understand what these applications of blockchain are, right? So first of all, let's talk about cryptocurrency, which is a major application. By the way, these all are major applications, but yeah, so since all this started with cryptocurrency, I'm mentioning it as that. So cryptocurrency is digital asset, uh, and yeah, so it's basically a digital asset. We can say uh, it's basically a currency in a digital blockchain network. So few things, if you might have heard of Bitcoin or uh, other popular blockchain cryptocurrencies, right? So few are, yeah, few things I want to highlight. These are highly volatile. So what does that mean? So they're highly volatile means in terms of their market price, they fluctuate a lot, right? So they aren't stable to the um, traditional currencies like the US dollar and all, you know, traditional currencies. But if you see, even to solve this, there have been few concepts like stable coins. So what stable coins do is these are cryptocurrencies which, it's the word itself says that stable, right? So they are pegged to fiat currencies. So pegged to fiat currencies mean that they are linked in a sort to the fiat currencies like the US dollar, or you know whatever the Japanese anything. So these all major traditional currencies. So this way, this solves the high volatility issues of cryptocurrency. And some are pegs, some are not pegs. So major cryptocurrencies are like Bitcoin, then Ethereum, Ethereum's ETH, Polkadot's Dot, and Solana's Sol. So this is basically cryptocurrency in a nutshell. And next I want to talk about is smart contracts. So these are basically uh, programs uh, which are similar to any other program that you do in the web 2, like a Java program or Python program, right? So this, the thing about these smart contracts is this mean contract, right? So contract means agreement, right? So there has to be, this mean that there's a predefined condition, and only after these conditions are met, that this this can be executed, right? And few things are, there's like no middleman in this. So, and immutable, meaning that they can't be changed once they are put into on, they are onto the blockchain. They can't be manipulated, they can't be deleted in any way. So it's public, by the way. So when you put it on a blockchain, so it's public, anyone can view these smart contracts. And also for this there are languages. So here it's an example of Solidity language, which was developed by Ethereum blockchain. And there's also Viper, which is another. Then Move is a language for Aptos blockchain, and you can use Rust for Solana as well. So these are all basically technological, the deep coding stuff. So, and next I want to talk about is DApps or decentralized apps. And what this mean these are smart contract apps which use all the smart contract code and smart contracts and some, yeah, so these are basically the app, any similar app built in the web 2 world, but the only catch is it's decentralized, right? So one such example is, there are a lot of examples, but the popular ones, Uniswap is a DEX, which is a decentralized exchange on Ethereum. Then Aave is a decentralized lending protocol. There's also MakerDAO, which is a DAO on Ethereum, which we'll get to what DAO means. And so, yeah, these are basically, in short, apps built on in a decentralized manner or built in blockchain. Now, let's talk about the major or the most biggest use case, which is DeFi. And DeFi is basically decentralized finance. What does that mean? So, now, since everything started with transaction records and who owes what and all that, so traditional finance definitely comes into play, and that's what DeFi is. So it aims to solve the financial aspect and making it decentralized. So there's no single authority controlling things. And here we have CeFi versus DeFi, which means, like, if we talk about centralized finance, the way we talked, of the 2008 financial crisis, where all these financial institutions involved were centralized financial institutions, right? And what they had the authority or total control over the financial ecosystem, and that's what DeFi is trying to solve to, you know, uh, uh, dismantle all the centralized uh, power and making it into the power of decentralized institutions. So major use cases can be are financial services like DEXs, which are decentralized exchanges. Then there's MakerDAO, then Compound. These are basically protocols. Protocols mean ones which follow set of rules, which are certain rules that and built on top of that rules. So these are basically application protocols which are the finance related. And DeFi Llama is where you can see all these major uh, use cases of DeFi. Like, for example, let's just go to DeFi Llama. So if you just go to the DeFi Llama website, you can see the total value locked. As of now, total value locked is, yeah, so it's the current value, and you can see all the statistics from 2019 and all the protocols. Like I said, MakerDAO is one, then Aave is there, Uniswap, and all these major protocols are here. You can even see the chains listed on this, like the Ethereum blockchain, Solana, or Arbitrum, Polygon, and all the valuations and the DeFi use cases they have. So let's just get back to this. Now that's basically what DeFi is. Then we talk about NFTs. So NFTs mean non-fungible tokens, right? Now what does that mean? So these are digital tokens which are unique and authentic. Now, why do I say these are unique and authentic? Because these are some things that can't be exchanged with one another, right? So if let's just say you have paintings, right? Some great author made it, and let's just take the Mona Lisa painting, right? So you just can't exchange that painting with some other painting made by the same artist, right? Because they are unique in their ways, right? So they are authentic in their ways, and that's basically what digital tokens mean. So these might be paintings, this might be creative artwork or anything related to that, and they are unique, they are authentic again, and yeah, this all the process is basically tokenization, meaning to convert these digital assets to tokens and making them unique from each other. So, for example, Gitpops is something which I love and came across, and I think I should show it to you. So, Gitpops is Gitpops is basically like a certificate, or oh, I think I messed up. Yeah. So this is basically great example of NFT, and if you are into open source and into the blockchain, so these are something like certificate awarded on your contribution levels. So if you contribute heavily into open source and all these protocols, so this is something you can aim for. It's pretty cool. If you see, this is pretty unique, so unique from each other, and this is what NFT is all about. I love the use case here. So yeah, and yeah, that's pretty much it. So these are NFTs, and by the way, I'm even wearing one. So these are all cool NFTs. Uh, this was, I think, the Monkey Yacht collection or something like that. But yeah, this is the NFT thing, and yeah, the DAO. So DAOs are basically decentralized autonomous organization. You can think of it in sort of sort of company, but there are predefined rules in this. These all autonomous organizations use blockchain and operate according to the blockchain. That's what makes them autonomous, right? So there are few participants. They have voting rights. They have stakes put in into the organization, and there are governance models, which have set of rules, set of protocols defined, and all the decisions take place according to these governance models. So yeah, it's you can think of it as a democracy, right? And a group of people into that democracy, right? Just majority voting gets the decision implemented. That's pretty much all the applications of blockchain. And yeah, so now I want to talk about web3.js. And so basically this video was divided into two sections, and the first section is wrapped up, where I explained the blockchain basics, and which covered its origin, working, applications, and pretty much everything you are expected to know about the blockchain jargon. And now the second section is web3.js. So what is web3.js? I want to walk you through this web3.js library, which web3.js is a JavaScript and TypeScript collection library, and which allows to interact with Ethereum blockchain, or we can say the Ethereum smart contracts. Uh, Now, first thing I want to talk about here is uh, why Ethereum and why build DApps or decentralized apps on Ethereum. If right now we see uh, the TVL on Ethereum, it's somewhere around uh, 80 to $100 billion, and which is pretty much major than other blockchains. And so the total value locked on Ethereum include major protocols like Uniswap, Aave, SushiSwap, and Compound. So these are all big players in the DeFi space, right? So I think that's the very reason why you should consider building on Ethereum dApps, right? And that's where Web3.js comes into play. Uh, what it does is uh, I want to give it into I want to set into a brief section that so dApps or decentralized applications, which are also like web apps, you can consider them web apps, talk to Ethereum, right? As they are built on Ethereum. So what Web3.js does as a library, it allows or enables app interaction with Ethereum nodes. So Ethereum nodes are basically, you can think of them as servers, but they are decentralized and so not on any specific central authority. And that's what Web3.js enables, to talk to these Ethereum nodes and do the basic applications like uh, data querying, accounts, and transaction handling, etc. So this is what Web3.js does. It's very brief. There are a lot of other things happening behind. So let's just talk about what happens behind the scene and how Web3.js works behind the scene, right? So this is a this is a diagram I have provided. Um, so you can check out on Ethereum book on GitHub, and yeah. So what happens is Web3.js connects with Ethereum by connecting to the Ethereum nodes like local machine or Alchemy. So what it does is, here you can see your web app, right? So this is a client's browser, and let's say you are building a web app, and this is basically the Web3 world, right? So what you do is, now you don't have a way to interact with Ethereum as uh, of now, right? So you use Web3.js as your library, and then you uh, make a call, RPC JSON call, so which is a remote procedure call to the Ethereum provider, or and the Ethereum the provider then interacts with the Ethereum blockchain, and it in return it provides all the data like querying and giving the account details and records. And yeah, so what it does is the library connects to these nodes using HTTP or WebSocket or JSON RPC protocols, right? So, so JSON RPC makes requests to Ethereum providers, and these protocols are encoded in JSON, which is a JavaScript object notation, and JSON RPC takes care of all these requests, and all you need to do as a dev is only interact with the functions provided by Web3.js. Here, a few things you can see are what, yeah. So, so this layer is basically the communication layer between the your app and Ethereum nodes, and this handles the uh, sending transactions, requests, and receiving responses from the node. And whereas a provider, where even wallets like MetaMask can be injected as a Web3 provider into the browser, these allow the application to interact with the blockchain to users account. So that's how in brief how Web3.js works. And so to get started with Web3.js library, first of all, let's visit their official website. So you can just search for Web3.js, and this is the official website. And this is docs, and here move to quick start, and these are the installation steps. So here, so you can even install Web3 via npm package manager or yarn as a package manager. Uh, for that, before that, you would need Node.js installed. So make sure you have this package Node.js installed on your local system, and yeah, that is good to go. So let's just pull up the terminal, and I will cd to the blockchain basics in code. So first, what you need to do is initialize the npm package manager. So let's just do that. Npm init/y. So all the permissions are given, and we are good to go. And then the first step is to install web3, npm install web3 or npm I web3. So while doing that, as we discussed, whenever we use web3 as library, we need to have a provider, right? So what providers do, as discussed, they are services that are responsible for making the connectivity possible with the Ethereum network. And you can use providers like Infura or Alchemy or other providers, and you need to give it a link. So let's just go to the provider. So I'm going to use here Alchemy as my provider. So this is the official website of Alchemy, and here we have web3 installed. And yeah, okay. So let's just get the provider first. Make sure you sign in, and here's the my app section. And when you go to networks, you will see an interface something similar to this, where you can see here Ethereum and mainnet. So you can uh, copy the link from here for mainnet, as well as if you're compatible with mainnet, you can do that, as well as you can use the testnet link. So I've just copied the mainnet link, and once you got that, let's just create a file, index.js. And what we'll do here is write the code for importing web3.js. So you can import it in two ways: the classic, common JS style, or native ECMAScript. So whichever way you're comfortable with, I'm going to use your const uh, web3. So we are going to require web3, and then we'll create a new instance of web3, sorry, web3. And what you need to do is provide the RPC link, the link to the provider here. So I'm going to paste here my link. So this is my Alchemy provider link in my web3 instance. And what we'll do further is, now we'll get a hold of the block number. So this method from the library gives you the block number, and the then is promise. You can even use async await promise, async await syntax to do that. I've used here the then promise syntax. So this basically gets us the hold of the block number, and what we are going to do is console log the block number. And yeah, so I've saved the file. So let's just run the file, node index.js. So yeah, I've got here a warning, but uh, it's fine. It's nothing, some update. And we have here our block number. So this is one of the methods which can which you can use from the web3.js library. There are multiple other methods, so it's very vast, and that's basically all of. You can even query the blockchain. You can set up the wallet and transfer and a lot of other things. So this is basically a very good start to get you started if you're on your blockchain journey. And yeah, if you found this video useful, make sure you follow the ChainSafe channel to get more updates on this tutorials of Web3.js library. And yeah, make sure you follow us, like the video, comment, and yeah, I'll keep bringing these videos if you find them informative. Thank you. Bye.